The chemistry of rocket propellants. A propellant is a chemical mixture consisting of a fuel and an oxidizing agent. When it is burned, it produces a thrust in the rockets. Heat energy is added to the propellant, which results in a combustion reaction. The fuel is combined with O2 and burned to produce expanding gases. The oxidizing agent is the substance that releases oxygen or gains electrons through the transfer of oxygen to its substrate. The two most common types of propellants that are found are liquid and solid propellants. Solid propellants are the simplest of rocket motors. The solid propellant is a mixture of an oxidizer, a fuel, both in powdered form, and a binder. The solid propellant mixture is put in a casing, metal, usually steel, with a grain or something to stabilize the combustion. As the propellant burns, expanding gases are expelled out the bottom through the nozzle. This provides the thrust for the rocket and propels the rocket upwards. It is important to note that once the combustion of solid propellants begins, it must go to completion. The chemical processes behind the propellant are quite simple. The oxidizer and fuel are mixed together homogeneously and bound together with a liquid binder that would be evaporated off or one that does not take place in the reaction. The mixture is then heated, which allows for combustion to occur. A common solid rocket propellant, oftentimes called rocket candy, is made with potassium chlorate, the oxidizing agent, and sugar or sucrose, the fuel. The reaction is modeled by the following chemical equation. As you can see, as a result, there are many moles of gas. The second type of rocket propellant is liquid propellant. In rockets with liquid propellant, the fuel and oxidizer are stored in two separate compartments and fed through a system of pipes and valves into a combustion chamber. There, they are combined and burned to produce thrust to power the rockets. The advantage to these liquid propellant rockets is that the reaction can be controlled, unlike that of solid rocket propellants. There are three types of liquid propellant: petroleum, cryogenic, and hypergolic. Petroleum propellants use fuels that are refined from crude oil and are a mixture of complex hydrocarbons, also known as organic compounds containing only carbon and hydrogen. This is then combined with liquid oxygen, which is the oxidizer. Cryogenic propellants are liquefied gases stored at extremely low temperatures. Because they have to be stored at extremely low temperatures, this can often cause problems when they are being stored. The most common type of cryogenic propellant uses liquid hydrogen as fuel and liquid oxygen as oxidizer. Cryogenic propellants are often higher efficiency than other liquid propellants. The last type of propellant is hypergolic. Hypergolic propellants are fuels and oxidizers that ignite spontaneously on contact with each other and require no ignition source, making them ideal for spacecraft maneuvering systems. Also, since hypergols remain liquid at normal temperatures, they do not pose the storage problems of cryogenic propellants. Hypergols are highly toxic and must be handled with extreme care. Hypergolic fuels most commonly include hydrazine, monomethylhydrazine, and unsymmetrical dimethylhydrazine. The oxidizer is usually nitrogen tetroxide or nitric acid. I hope you've been educated on rocket propellants, and thank you for watching.